Hi everybody, this is Tim Urdan, author of Statistics in Plain English, and in this video we're going to conduct a mixed model ANOVA in R. So if you are not familiar with the R Studio setup and the 4 different windows in it, take a look at another video that I made called Descriptives and Overview of R. So that kind of explains these different windows. So a mixed model ANOVA is one where you have a within subjects factor. That is generally where you're measuring either the same variable with the same sample over multiple time points, or you can also have different variables that you want to compare to each other, but measured within the same sample. So you're looking at changes within individuals in the sample over time in their averages, or across variables in their averages. That's the within subjects factor. And then that is just a repeated measures ANOVA. But if you add a between subjects factor, this would be a categorical variable, then you've changed your repeated measures ANOVA into a mixed model ANOVA. So this will show you sort of how to do a mixed model ANOVA, but within this you can see there's also information about how to run a repeated measures ANOVA. So this first line is selecting the data. That is telling R which variables in the data set you want to include in your analysis. And what we've got here, we've got the ID, which we always import. That's the IDs, identification numbers for each case. And now I've got class performance wave 1, class performance wave 2, and wave 3 class performance. Class performance are, this is a high school sample, and we asked the students to tell us whether they thought there was an emphasis on competition and doing better than other students in the classroom. And what we wanted to see is how students' perceptions of the competition focus in their classroom changed over time. So wave 1 is the fall semester of the first year. Wave 2 is the spring semester of the first year. So these students are in the same class for the whole year, so we're checking to see whether their perceptions changed over time within the classroom. And then wave 3 is the fall semester of the next year, so when students would have switched into a new classroom. So we want to see whether their perceptions of the competitive focus in classrooms change within the school year from wave 1 to wave 2, and then across school years from wave 2 to wave 3 as students move into new classrooms. So let's run this. Okay. Next, we are telling R that this wave 3 compete DI should be treated as a categorical variable. Wave 3 compete DI is a dichotomous variable. It was originally measured on a continuous scale, but I made it dichotomous to form 2 groups, a highly competitive group and a low competitive group. So I'm thinking maybe students who are kind of low in competitiveness don't really view a lot of changes in the competitive focus in their classrooms, and students who are highly competitive may be more likely to view changes in the competitive focus in their classrooms over time. So I'm going to run that. Okay. And now here, we're going to run that so that we're telling the program R to recognize these variables as longitudinal measures, as repeated measures of the same construct over time. And now we'll get a summary of these variables that are included. This is the ID over here, which is not interesting. The competition variable is these are just numbers of cases in them, it looks like. And the minimum value, first quartile, median value, mean, third quartile, and max. These are, if you were to take the 3 waves of data on the classroom level of competition, the 3 variables, class performance wave 1, class performance wave 2, and wave 3 class performance, and you were to combine them into one overall perception of the classroom competitiveness, that these would be the statistics that you would get: the minimum, the first quartile, the median, the mean, the third quartile, and the max. So this is combining the 3 repeated measures across into one big variable. And I don't know if it's all that useful to try and interpret that data, but that's what it's doing. So next, let's get some descriptive statistics. That is up here. Run this. And what this tells you is the sample size, mean, standard deviation, standard error of the mean, and range of the 95% confidence interval for each what we would call cell in the analysis. So 0 is the low competitive group, students who define themselves as not being very competitive. And this is the data for that group on class performance wave 1. Their perceptions of the emphasis on competition in their classroom in the first wave, which is the fall of the first year. So you get descriptive statistics for the low competitive group on each of the 3 variables in the longitudinal analysis. And you can see, if you look at these means from wave 1 to wave 2 to wave 3, within this low competitive group, all of these values here are 0, telling you this is the low competitive group, that their perceptions of the classroom environment don't change very much from wave 1 to wave 2, but then drop at wave 3. So within the school year, they stay pretty much the same, but then their view that the classroom is a competitive place declines when they move to a new classroom the next year. If you look at the highly competitive group, these are the ones with values of 1 here. Here is their descriptive data for wave 1, wave 2, and wave 3. And what I can see from looking at the means across these 3 waves is that there's very little change in their means, even when they go from one classroom to a different classroom the next year. I can also see that the means are all around 3.0, and the means for the low competitive group are all around 2.5, and then they drop to 2.29. So just looking at these descriptive data, I can see what's going on a bit. I don't know if these differences are statistically significant, but 2 things jump out. One, the students who say that they themselves are more competitive are more likely to view the classroom as a competitive place than those who don't see themselves as being competitive. And 2, that there's not really any change in the perceptions that the classroom is a competitive place among the highly competitive students, but there does seem to be a change amongst the students who are low in personal levels of competitiveness. So it looks like there might be an interaction going on there where there's a change within this group over time, but there's not really a change within the highly competitive group over time. So something to keep our eye on. Now we run the Anova. That is this line here. And this last part here says, tell us the effect size as well. And the effect size will be partial eta squared. So let's run that and see what we get. All right. So our Anova test looks at these different effects. This right here is the between subjects effect. Is there a difference between high competitive and low competitive students in their views that the classroom's a competitive place? The F value here is very large. The P value is tiny. It's statistically significant, and the partial eta squared is 0.136. So the significant difference between the high competitive and low competitive group in their overall views of the emphasis on competition in the classroom explains about 13.16% of the variance in perceptions of the classroom competitive environment. Variable right here is what they call the between subjects. It's what they call the within subjects factor. So this is saying, are there significant changes over time in students' perceptions that the classroom is a competitive place? This is when you combine the high competitive and low competitive groups together. Overall, among all of the participants in this study, is there a change over time in their average views of the classroom as a competitive place? F value and P value. F value is large, P value is statistically significant, and partial eta squared, 0.02. So this effect explains 2% of the variance. And then this is the interaction between change over time and the between subjects factor of personal level of competitiveness. Here is the F value and the P value. We see that's statistically significant, and that little asterisk also tells us it's significant. And then the partial eta squared says that the interaction effect explains an additional 1% of the variance. There is an assumption that the variances are equal across the different waves of data collection. That is called a sphericity assumption. The test for this assumption is called a Mauchly's test for sphericity. And you test the within subjects factor and see that that is statistically significant. And you test the interaction effect and you see that that is statistically significant. And what you know when the Mauchly's test is significant is that the assumption of sphericity has been violated. So we have unequal variances across the three measures of the within subjects factor. And when you violate that assumption, most stats programs, SPSS and R included, will make corrections. And what they do, so when you violate that assumption, it's telling you that you're more likely to make a type 1 error. You're more likely to find a statistically significant effect when there isn't one. And so to adjust for this, you just reduce the degrees of freedom. Smaller degrees of freedom makes it harder to find a significant result. So our degrees of freedom up here was 1362. Our degrees of freedom down here has been adjusted to 1332. So it reduced the degrees of freedom and then tested again to see whether the result was significant, and the result for the main effect of the within subjects factor is significant, and the result for the interaction effect is also significant. So even with the adjustments, we can see that these effects are significant. All right, that's all the statistics. Now we interpret the results. So we have a main effect for the between subjects factor here. That tells us that up here, when we were looking at the differences between the means of the 0 group and the 1 group, the low personal competition people and the high personal competition people. These differences in the means that we saw are statistically significant. Highly competitive people are more likely to view the classroom as being a competitive place, as emphasizing competition. The main effect for the within subjects factor is also statistically significant. That tells us that there overall is a change when you combine the two groups together. There's a change over time in how competitively or how competitive students view the classroom. And that's mostly being caused by this right here. So there is a drop on average over time in, it looks mostly like it's from time 2 or time 3 compared to time 1 and time 2. There's a drop in the average levels of perceiving the classroom as being a competitive place when students move into the second year into a new classroom. But you've got to be careful, because this significant interaction effect tells us that this drop doesn't look the same for both highly competitive students and low competitive students. And if we look up here, we can see that that drop, that decline in perceiving the classroom as a competitive place, really only happens in the low competitive group and does not happen so much in the high competitive group, where the decline is much smaller. Okay, so that is how you run a mixed model ANOVA in R.